In this lesson, we continue on with finding intersection of linear systems, or solving the system, or finding the solution that satisfies the equation. So let's go back to look at a table of values. You should be able to find the equation of a table of values if you can determine the first rate, or first differences, or which is the rate of change. Let's just get a pen here. So first differences, sometimes called finite differences, are going to determine your rate of change. So that is the change in the y compared to the change in the x. Remember that a linear equation is y equals mx plus b, where m is the rate of change and b is the initial value. So if we have this table of values, we can look at how the y is changing. If I go from -1 to +3, I'm increasing by 4. If I go from 3 to 7, I'm increasing by 4. 7 to 11, increasing by 4, and so on. So I see that constant rate of change, which tells me it's a straight line. And if I compare that to how x is changing, x is going up by 1. So in this case, the y is increasing by 4 when the x is increasing by 1. Then I want to look at my initial value, which is where y has a value when x is 0. So the initial value, we are looking for what is the value of y when x equals 0. Right? That's my starting point. And in this case, it is -1. So when x is 0, y is -1. So I can write the equation of this table of values represents a constant change of 4, starting with an initial value of -1. Then we might want to solve a linear system. So here I can see that the intersection point is at 1, 1. We might also call that the solution. So how do we know what these lines are? How can we check to see if this point is correct? Well, we should be able to find the equations of these lines by looking at the rate of change and the initial value. So remember, we have a rate and we have an initial value. So let's look at the line here. This has an initial value of 0, 0. So we'll call this line 1. So I'm looking at the value of y when x is 0. So the initial value on this graph is at 0, 0. So y is 0 when x is 0. What is the rate? Well, if I go to the next point, when I increase x by 1, I go up by 1. Increase x by 1, up by 1, and so on. These are going to give me points on this line. So the rate of change, what I'm looking for is how does the y change compared to how does the x change. So when x increases by 1, y is increasing by 1. So the rate of change is 1. So this equation would be a rate of change of 1 for each x and a starting value of 0. If I do the second line, it has initial value at 3. We'll call this line 2. So line 2 has an initial value at 3. So that point would be 0, 3. Initial value of 3. What is the rate of change? Well, it's going down, so it's negative. So when I increase x by 1, I'm going down by 2 to get to the next point. X increases by 1, y goes down 2. X increases by 1, y goes down 2. So my y is going down by 2 each time I increase the x by 1, or I could say just -2. So the equation of this line is we go down 2 for each x, and then we started at an initial value of 3. So that equation would be -2x plus 3. So now I can check my solution in both of these equations to see if it is correct. So this equation is y equals -2x plus 3. And this equation was y equals 1x plus 0. We don't really need the 0, but we'll write it in there. So we think that the solution was 1, 1. So when x is 1, y is 1. So 1 times 1 plus 0 is 1, so it checks in that one. And y is 1, x is 1. Negative 2 plus 3 is 1, so it checks in that one. So we should be able to find the equation of lines given a graph, and then we should be able to solve the intersection point and check our solution. We might have some word problems or some applications. So in this question we have two people that are tutoring. So William charges $15 up front, that's a flat rate, and $3 per hour. So William charges a flat rate of $15. So that is the initial value. Then he charges $3 per hour. So that is the rate of change. So if we're writing an equation, we would say y equals $3 per hour plus $15 flat rate, where x is number of hours that he's going to tutor and y is the total cost. If you wanted to use different variables, you could say y represents the cost and x represents the number of hours. It doesn't really matter what variables you use. Sometimes it makes more sense to use letters that represent what you are calculating. Okay, Patrick charges a flat rate of $20. So that's his initial value. And then he charges $2 per hour. So he has a higher flat rate but a lower hourly cost. So that's his rate of change. And so his equation would be $2 for each hour plus $20 up front. Or again, if you wanted to use different letters, cost is $2 per hour plus $20. So that's Patrick and this is William. So once you have done that, you want to graph each equation and state the point of intersection. And then we want to pick which tutor we would hire and when. Do I have a table here? I don't. So let's just put it on a grid. We'll just add a grid here. Where is my graph paper? Well, I can't find any graph paper, so we'll just make a grid. So if I were graphing, the x-axis would be the independent or number of hours, and the y-axis would be the cost. We could make a table of values for each if you're not sure how to graph this. If you don't know how to use the rate of change in initial value, we can make a table of values. So we would start with 0 hours because we can't have negative hours, and I might go up by 1 hour. Okay, so this is William. So for 0 hours, he's $3 an hour plus 15. So 0 hours would be $15. And then we're going to add $3 for each hour. And then we have Patrick. And we'll do the same. We'll go up by an hour each time. So he charges $20 for 0 hours plus $2. So we're going to add $2. And we'll get some values. So we can see in the table that for 5 hours, William charges $30. And for 5 hours, Patrick charges $30. So you might find the answer in the table. Maybe, maybe not. If I'm doing my graphing, let's do 5, 10, 15, 20, 25, 30. So we'll go up by 5s. Okay, so William starts at $15 and he's going up by $3 each hour. Okay, so he would be at 1 hour, he's approximately there. At 2 hours, he's a little over $20. At 3 hours, he's at 24. At 4 hours, he's at 27. So since I don't have grid paper, it's a bit of an estimate. So there is William, and then we'll do Patrick in red. So he starts at $20. 1 hour, he's at 22. 2 hours, he's at 24. 3, and at 5 hours, he's at 30. 4 hours, he's at 28. So Patrick looks something like this. And we know that that intersection point is at 5 hours. They both cost $30. So at 5 hours, both charge $30. So who is better when? Well, the lower line is the cheaper cost. And so before 5 hours, if I'm using less than 5 hours, so if I need tutoring for less than 5 hours, I would choose the blue line, which is William, because he is the lower cost. If I'm using the tutor for more than 5 hours, then Patrick becomes the better choice because now he is the lower line. So in order to determine which one is best, we have to determine when they're both the same, and then we can see who is cheaper before that point and who is cheaper after that point. You can also solve algebraically, which is a little bit trickier, but you know how to solve equations. So let's have a look at that. So you can also solve algebraically. So if the cost for Patrick is $3 per hour plus 15, and the cost for William is $2 per hour plus 20, we can find out when are they equal by making the equations equal to each other. So when is 3h plus 15 equal to 2h plus 20? So I'm solving for h. So I'm going to get my variables on the same side. So I'm going to get rid of them on the left and put them on the right. So 3h minus 2h is 1h. And that gets rid of that. And then I will isolate for h. So let's get rid of the 15. So if you know how to solve an equation, that's very helpful. We can solve algebraically without doing the table of values, without graphing. And solving algebraically is the most accurate way to determine the intersection point. Table of values, the answer might be there, it might not. In this case it was, but it's not always visible. When you graph, it's more of an estimate sometimes because you can't always be as accurate. So solving algebraically is the most accurate way to solve a system.